Bismillahirrahmanirrahim. The last part, we spoke about the reference angle for a given theta. And we say that we have four cases. Either theta is in the first quadrant, in which that theta equal to theta prime or the reference angle. If theta is given to be in the second quadrant, then the reference angle is equal to 180 minus theta. And if theta is given to be in the third quadrant, then the reference angle theta prime equal to theta minus 180. And if theta is in the fourth quadrant, then it is 360 minus theta. In this part, we are going to discuss how to find or how to evaluate trigonometric function for given theta that are not in the first quadrant. Start with this procedure. Suppose that we have theta to be non-quadrantal angle. And we said non-quadrantal. Quadrantal means 0, 90, 180, and 270. These are quadrantal angles. And now we are speaking about non-quadrantal angle. It's just an angle where the terminal side is not on the one of the x-axis or y-axis. So let theta be a non-quadrantal angle in standard position with reference angle theta prime. To evaluate a trigonometric function of theta, we use the following procedure. First step, we need to find the reference angle. Second step, we need to find to determine the sign of the trigonometric function of theta, because we know that we have different sign. If it is in the first quadrant, all of them are positive. If it is in the second, then we have sine and cosecant are positive. If in the third quadrant, then it is tangent and cotangent are positive. If theta is to be in the fourth quadrant, then it is cosine and secant are positive. So in the second step, we need to determine the sign of the trigonometric function of theta. Third step, the value of the trigonometric function of theta equal to the value of the trigonometric function of theta prime with the correct sign. To explain this in detail, let's have these examples. We need to evaluate or find the exact value of each trigonometric function. Question number 49. We need to find sine 225. Let's see this. 225 is in the third quadrant. And the reference angle theta prime in the third quadrant, theta prime equal to theta minus 180, which is 225 minus 180 equal to 45. So the reference angle is equal to 45, which means that sine 225 is equal to sine of 45. But sine in the third quadrant is negative. Sine in the third quadrant is negative. So we need to write this sign, it is minus. So sine 225 equal to minus sine 45. So the idea is to find the reference angle for 225. That will be 45. And we know that the sign is negative in the third quadrant. So sine of 225 equal to minus sine 45, which is equal to minus square root of 2 divided by 2. So this is the value of sine 225. Second one, question number 50. Question number 50 says that we need to find cosine of 300. So cosine 300 is in the fourth quadrant. So theta prime equal to it is 360 minus theta, which is equal to 360 minus 300, which is equal to 60. Now, cosine in the fourth quadrant is positive. So this is equal to plus cosine of the reference angle. And the reference angle, we found it to be 60. So this is cosine of 60. That will be plus 1/2. So cosine of 300, which is in the fourth quadrant, cosine is positive. The reference angle is equal to 60. So this is equal to plus cosine 60, which is equal to plus 1/2. Take another one. That's question number 51, tangent of 405. Question number 51. We need to find tangent of 405. So let's find the reference angle for this one. And since this is greater than 360, we are going to find the coterminal angle. To find the coterminal angle, it is 405 minus 360 equal to 45. And 45 is in the first quadrant. So this 405 will be in the first quadrant. And the tangent in the first quadrant is positive. So this can be equal to, or can be written as plus positive tangent of 45, which is equal to plus 1. So the value for this one, tangent 405 equal to plus 1. Next problem is 52, that is secant of 150. Secant of 150. Now 150 is in the second quadrant. And the reference angle is theta equal to 180 minus 150, which is equal to 30. So the reference angle is equal to 30. And we know that the secant is negative in the second quadrant. So this is minus secant of 30. The secant of 30, which is equal to minus 2 over square root of 3. Or it is minus 2 square root of 3 divided by 3. Secant is 150 is equal to minus 2 square root of 3 divided by 3. Again, because the secant is in the second quadrant, so it is negative. So the value will be minus secant of 30. That equal to minus 2 over square root of 3, or minus 2 square root of 3 divided by 3. Number 53, cosecant of 3 or 4 pi over 3. Cosecant of 4 pi over 3. Now 4 pi over 3, this is either in the second or in the first quadrant. Let's see. If we divide 4 by 3, I will get 1/3. Or I can write it. This is 4 pi over 3. It can be written as 3 plus 1 pi over 3. Now 3 over 3 is equal to 1 and 1/3. So I will have this is equal to 1 pi plus 1/3 pi. So it is pi plus 1/3, which means it is in the third quadrant, because this 1 pi will be the end of the second quadrant and plus 1/3. So this is in the third quadrant. And in this case, if I remove this one by, I will have the reference angle, because the reference angle theta prime equal to theta minus pi, that will be 1/3 pi, because this is in radian now. If it is in degrees, I will say theta minus 180. If it is in radian, it is theta minus 1 pi radian. So the reference angle is 1/3 pi. So cosecant is equal to cosecant of 1/3 pi, or pi over 3. But cosecant in the third quadrant is negative, so we have to write a negative sign. It is minus cosecant pi over 3, which is equal to minus 2 over square root of 3, or it is minus 2 square root of 3 over 3. Pi over 3 is equal to 60 in degrees. It is one of the special angles. And cosecant is minus 2 square root of 3 divided by 3. One more. See question number 55. Cosine 17 pi over 4. Cosine of 17 pi over 4. So we need to check which quadrant is this. 17 pi over 4. Now 17 pi over 4. This is 17 pi over 4. Which is equal to, if we divide 17 by 4, it is 16 plus 1. I can say this is 16 plus 1 pi over 4. And 16 divided by 4 is equal to 4. So this is 4 pi. So I can write it as 4 pi plus 1 over 4 pi. It is 4 pi plus 1 over 4 pi. Now 4 pi, it is 2 pi plus 2 pi. It is just complete circle, 2 times. So if we take this out, the remaining is 1/4 pi. This is the coterminal angle. So I can say theta prime equal to 1 over 4 pi. Theta prime equal to 1 over 4 pi, which is in the first quadrant. And the sign of the cosine in the first quadrant is positive. So this can be written as plus cosine 1 over 4 pi, or pi over 4, which is equal to plus square root of 2 divided by 2. One more. Let's take cotangent of 540. That is question number 59. Tangent of 540. Now cotangent of 540. This is greater than 360. So we need to find the coterminal angle. We need to find coterminal angle first. That is theta prime equal to 540 minus 360, which is equal to 180. Now this is one of the quadrantal angle. So this is equal to cotangent of 180. But cotangent in the second quadrant or is negative for the second quadrant or the third quadrant. I'm sorry, for the second quadrant. But 180 is one of the quadrantal angle. So cotangent of 180 which is equal to cosine over sine, just to simplify it. This is cosine of 180 divided by sine 180, which is minus 1 over 0, and we know this is undefined. So it is undefined. So cotangent of 540, which is equal to cotangent of 180, is undefined. So this is how to find the exact value for angles given in the second, third, or fourth quadrant, or greater than 360. If these are less than 360, all what we need just to find the reference angle. If it is greater than 360 or greater than 2 pi in radians, we need to find the coterminal angle and then determine which quadrant to find the reference angle. Then we can find the exact value, whether it is positive or negative, depending on the quadrant.